Hey everyone, and welcome to today's Explainer. We are looking at a truly groundbreaking paper today, one that is fundamentally rethinking how AI interacts with data. We're moving way beyond the traditional ways language models fetch information, and we're exploring a brand new paradigm that is completely changing the way AI searches for and reasons over complex information. Honestly, for anyone who uses AI, builds with AI, or just wants to understand the absolute cutting edge of agentic search, this is going to be incredibly eye-opening. Okay, let's dive into this. With a quote from the famous media theorist Marshall McLuhan, he said, "The medium shapes and controls the scale and form of human association and action." Now, you might be wondering, why start an explainer on AI search with a philosophical quote from the 1960s? Well, because for an AI agent, its retrieval system literally is its medium. The way an AI searches essentially dictates how it perceives its entire world. If that interface is narrow, the AI's understanding is going to be narrow, no matter how incredibly smart the underlying model might be. Keep that idea in the back of your mind as we go forward. So, here is our cognitive roadmap for today. We're going to cover the AI retrieval bottleneck, meet direct corpus interaction, see how direct interaction actually works, dive into the performance, cost, and accuracy numbers, address the context window challenge, and finally, wrap up with the future of search. Section 1. The AI retrieval bottleneck, the detective locked out of the file room. To really grasp the problem with current AI search, I want you to imagine a brilliant detective. But there's a catch. This detective is locked out of the file room. This locked-out detective is essentially exactly how current retriever-mediated retrieval, which we often call RAG, works today. In a standard RAG system, documents are chopped up into chunks, converted into mathematical vectors, and then indexed offline. When the AI agent actually needs information, it can't just browse the files itself. Instead, it has to hand a query to a clerk, the retriever, and ask for, say, the top 5 most similar snippets. And the AI's reasoning only starts after this retrieval step. But think about it. What if the clerk misses a vital, subtle clue in that early filtering stage? What if the whole connection relies on finding one obscure entity to link to another? If the clerk doesn't bring back the right files in that top slice, our brilliant detective fails before the investigation even gets off the ground. The semantic understanding is essentially pushed way up into an offline index, and that creates a massive bottleneck for capable agents. Section 2. Meet direct corpus interaction, giving the detective the keys. You guessed it, it's time to bypass the clerk and just give the detective the keys to the file room. So the crucial point is the stark contrast between these two paradigms. On the one hand, retriever-mediated access forces the AI to look at the world through a pre-computed offline index, which inevitably results in semantic loss. But on the other side, we have direct corpus interaction, or DCI for short. In DCI, there's no offline embedding bottle. There is absolutely no vector database. There's no middleman at all. The agent bypasses the index entirely and explores the raw corpus directly, using the exact same general-purpose terminal tools that a human software engineer uses. All that complex semantic interpretation, it's delegated completely to the AI itself. And this brilliantly illustrates the architectural shift. Just picture the traditional retriever-mediated approach. You've got this clunky, complex pipeline of index building, the deployed retriever, and the poor AI agent restricted to reading those little top-case snippets. Now flip over to direct corpus interaction. That whole index building phase, completely gone. The agent issues raw command line interface commands directly into the raw corpus. It executes initial broad searches, looks at the exact text, and then refines its search based on what it just learned right there in real time. It's a totally unmediated, high-resolution connection to the data. Section 3. How direct interaction works. The magnifying glass. So let's look at the actual mechanics of this. If the agent is suddenly inside the file room, what exactly is its magnifying glass? Well, the DCI agent uses standard terminal tools. It uses bash to string its commands together. It uses grep for exact lexical matching, meaning it's finding specific strings or patterns in the text without having to rely on fuzzy semantic similarity. It uses find to navigate directory structures, reach to inspect the local context around a match, and it can even whip up lightweight Python scripts to process information. And because the agent is smart enough to formulate its own hypotheses, it can compose these primitive tools on the fly. It can search for a keyword, pipe that result directly into another search, and grab just the first 10 lines of the output. It grants the agent this highly flexible, composable, high-resolution interface to verify exact text. What's truly fascinating is seeing how the AI actually behaves when you give it these tools. The data here breaks down the tool calls across hundreds of complex queries. Over 62% of the time, it relies on bash. But look a little deeper into those bash intents. It isn't just mindlessly reading full documents. In fact, full document reads make up less than 10% of what it does. Instead, it spends most of its time on chain search, piping one search into another to combine weak clues, and document peek, using commands to verify exact local context. It behaves exactly like a methodical human researcher tracking down a really difficult bug. Section 4. Performance, Cost, and Accuracy. The data breakdown. Now that all sounds great in theory, but we have to ask the million-dollar question. Does this actually work better than our highly optimized vector databases? Let's look at the hard data from the BrowseComp-Plus benchmark, which specifically tests complex, deep research agentic search. The results are honestly staggering. When the researchers replaced a traditional retrieval tool with the DCI setup on the exact same base model, Claude Sonnet 4.6, they saw a massive 11 percentage point spike in accuracy. And because the agent could precisely target its searches rather than just churning through massive expensive chunks of top K retrieved text, the cost to run the evaluation set dropped by a whopping $424. So we're talking way better performance at a much lower cost. We can see this mapped out really clearly when we look at the Pareto frontier of performance versus cost. Traditional retrieval agents are stuck lagging behind, but those data points way up in the top right, that's the DCI agent using Claude Sonnet 4.6, vastly outperforming everything else. Also, pay attention to the best efficiency area in the top left. That is DCI Agent Lite, running on a much smaller, cheaper model called GPT-5.4-Nano. It somehow manages to achieve higher accuracy than much more expensive traditional retriever setups while keeping costs incredibly low. It just hits the absolute sweet spot. But why is it winning? Well, there were 176 complex questions that only the DCI agent got right, while the traditional retriever completely failed. The researchers found that DCI doesn't win by magically surfacing more total documents. In fact, standard retrievers often surface the gold documents just fine. The difference is that a standard retriever might hand the AI a snippet that frustratingly cuts off the crucial next hop. DCI wins through fine-grained localization. Once it finds a promising document, it probes it directly. It extracts concentrated evidence, verifies exact spans of text, and leverages that high-resolution access to connect the dots that traditional retrievers simply drop. Section 5. The Context Window Challenge, when the file room gets too big. Now, direct corpus interaction is incredibly powerful, for sure. But we need to be balanced here. It has a very clear operating envelope, particularly when it comes to scaling up. When the candidate space is artificially expanded from 100,000 documents to 200,000 and then up to 400,000 by adding a bunch of distractors, the cost and latency of locating that very first useful anchor document grows sharply. The agent just has to run far more broad keyword searches to find a starting point. At 200,000 documents, accuracy drops by 13.6 percentage points. The caveat is clear. DCI is unparalleled for deep, complex local searches, but it currently struggles with broad, needle-in-a-haystack discovery across massive, hundreds of thousands of document-scale datasets without a traditional index to help narrow that initial field. Let's move to and see how this builds into the other major challenge, the AI's memory. As the AI runs command after command, reading snippets and scrolling through file lists, its context window fills up incredibly fast. Without some kind of intervention, a long investigation will simply crash the model. So the researchers had to implement clever runtime context management to balance remembering past clues with making room for brand new observations. They utilized 3 specific steps to handle this memory issue. First, truncation. This simply caps the text returned from any single tool call so one massive file doesn't just blow out the memory instantly. Second, compaction, automatically clearing the text from earlier searches and replacing them with brief placeholders to maintain the overall structure of the investigation. And third, summarization. If the memory is still too full, the system takes the compacted history and rewrites it into a short, model-generated summary of key findings, keeping only the most recent context totally intact. It is a really delicate balance of selectively forgetting things in order to keep reasoning forward. Section 6. The Future of Search. A paradigm shift. All right, let's bring this all together and talk about what this really means for the future of AI. Here is what you should absolutely take away from this explainer today. We need to stop viewing AI retrieval simply as a retriever design problem and start viewing it as an interface design problem. The bottleneck is no longer the AI's brain. It's the narrowness of the semantic interface it's forced to use to see the world. Direct Corpus Interaction proves that eliminating the offline index entirely is not only possible, but highly effective for deep reasoning tasks. Capable agents absolutely thrive when they are given high-resolution, unmediated, raw access to data. Which leaves us with this final, provocative thought. As models get even faster and smarter, what happens when AI agents no longer rely on human-curated, pre-processed indexes at all? What happens when they can navigate the entire digital world, composing tools, running custom scripts, and verifying facts using the exact same raw interfaces that human software engineers use every single day? It fundamentally changes what an AI agent is capable of doing autonomously. I highly recommend diving into the source material to see the raw traces of these agents at work. It is truly fascinating stuff. Thank you so much for joining me for this explainer, and as always, keep learning.